Welcome to my YouTube channel dedicated to space. In this video we will talk about nebulas and star birth, cosmic phenomena revealed. The birth of stars and the nature of nebulas are among the most fascinating topics in astrophysics. Let's delve into these cosmic wonders. Nebulas. Cosmic wonders of the universe. Nebulas, often referred to as the grand canvases of the cosmos, stand as vast, intricate clouds shimmering with colors and mysteries. A nebula, in its most basic definition, is an interstellar expanse made up of dust, hydrogen, helium, and a multitude of ionized gases. When gazing upon a nebula, one isn't merely observing a distant formation. Rather, they're witnessing the very cradles where stars are birthed, nurtured, and initiated into the vast cosmic family. Nebulae serve as the universe's natural nurseries, holding the secrets to the genesis and growth of stars. There's a diverse range of nebulae scattered across the cosmos, each unique in its formation, characteristics, and role. 1. Emission nebulas. A beacon in the night, emission nebulae are radiant expanses that produce their own light, casting vivid hues across space. Among them, the Orion Nebula reigns supreme in its fame, easily identifiable even to amateur astronomers. Its brilliance is attributed to the nearby young, scorching stars whose radiation stimulates the hydrogen gas within the nebula, causing it to emit its characteristic reddish glow. This phenomenon is akin to a neon sign, where gas, when electrified, radiates a distinct color. 2. Reflection nebulas. These nebulae take on a more subtle role in the cosmic tapestry. They do not have the capability to produce their own light. Instead, they act as mirrors, reflecting the light of neighboring stars. This results in a mesmerizing bluish display, a consequence of blue light being scattered extensively in various directions, more so than its other colorful counterparts. 3. Dark nebulas. Acting as the enigmatic silhouettes of the universe, dark nebulae are dense, compacted regions filled with gas and dust. These nebulae neither emit nor reflect light, and thus, they cloak themselves in obscurity. They obscure the luminous celestial objects behind them, much like a curtain drawn against a window of light, producing gaps or voids in the starry expanse, giving them the moniker, the shadows of space. 4. Planetary nebulas. A rather misleading term, planetary nebulae have no association with planets whatsoever. The name harks back to a time when early telescopic observations revealed formations that bore a vague resemblance to distant planets. In reality, planetary nebulae are magnificent shells of gas and dust, remnants ejected by stars in the twilight of their existence. As stars near the end of their life cycles, they expel their outer layers, resulting in these breathtaking formations that signify both an end and a new beginning in the cosmic cycle. Before continuing with the video, I remind you to subscribe to the channel and activate the bell, so you don't miss our videos on space. Star birth. The cosmic symphony of creation. In the vast expanse of the universe, nebulas stand as colossal canvases, showcasing the birth, life, and death of stars. These star-forming regions are testament to the dynamic processes that define our cosmos. The initiation of a star, an intricate ballet of physics and chemistry, unfolds within these stellar nurseries. The inception of a star begins with disturbances in the tranquil equilibrium of a nebula. External factors, such as the cataclysmic explosion of a nearby supernova or the gravitational influence of mammoth stars, can unsettle the gases and dust. This disturbance results in a gravitational collapse in the most condensed regions of the nebula, a collapsing that can span millions of years. Protostar formation. As this collapse ensues, the heart of this contraction witnesses the birth of a protostar. Material, with ever-increasing momentum, spirals inward, accumulating at this central region. This accumulation causes the protostar to heat dramatically. With rising temperature comes escalating pressure within the core, setting the stage for the next chapter in the star's formation. Ignition. The heart of the protostar now becomes a crucible. When core temperatures soar to a blistering 10 million Kelvin, the stage is set for nuclear fusion. Hydrogen atoms, under this immense heat and pressure, coalesce to form helium atoms. This nuclear fusion unleashes a staggering amount of energy, heralding the birth of a new star. It's a luminous beacon, an emergent entity in the cosmic tapestry. Main sequence star. After this dramatic ignition, the star, now radiant and vibrant, reaches a period of relative stability. It finds its equilibrium, striking a delicate balance between the inexorable pull of its own gravity, seeking to draw everything inward, and the radiation pressure produced by nuclear fusion, pushing outward. This stage, known as the main sequence, is where a star will reside for the majority of its existence. The Sun, for instance, is currently in this phase of its life. Stellar evolution and death. Yet, stars, like all entities, are subject to the inexorable march of time. Based on its mass, a star's journey through life varies. More massive stars live fast and die young, going through stages like supergiants, and culminating in spectacular supernovae explosions. Lesser mass stars, like our Sun, will expand into red giants as they exhaust their nuclear fuel, eventually shedding their outer layers and leaving behind a hot core, which cools and contracts into a white dwarf. The most massive stars might collapse further into neutron stars or even the enigmatic black holes, regions of spacetime where gravity pulls so much that nothing, not even light, can escape. An essential epilogue to this stellar odyssey is the legacy stars leave behind. As stars journey through their life stages, they spew out stellar winds, explode in supernovae, and eject enriched material into space. This material, laden with heavier elements forged in the fiery crucibles of stars, enriches the surrounding nebulae. This stellar detritus, in turn, serves as the raw material for future generations of stars and planets, ensuring that the cycle of cosmic creation continues, weaving a tale as old as time itself. Cosmic phenomena revealed. With the advancement in technology, particularly in space telescopes like the Hubble Space Telescope, we've been able to see these processes in stunning detail. Nebulae that were once just fuzzy patches in the sky have been revealed as intricate, beautiful structures, full of color and activity. Each image tells a story of the ongoing life cycle of stars, from birth to death, in a dance that has been going on for billions of years. Moreover, the understanding of nebulae and star formation provides insight into the chemical enrichment of the universe, the genesis of solar systems like our own, and the cosmic origins of the very elements that make up our planet and even our own bodies. We are, quite literally, made of stardust. We'd love to know what you think. Comment below and don't forget to subscribe to the channel if you haven't already. We thank you for watching.